And then tomorrow we're going to go over homework questions. We might do a little bit today, but then tomorrow we'll spend a little more time on homework questions with that worksheet. I think we'll actually get some class time to work on tomorrow's homework, the worksheet in class, which will be nice. So we can work on it all together in our groups. Because it's not going to be the puzzle time one. It's actually going to be like a practice review one on the section because it has better problems. The puzzle time one has kind of lame problems, so it wasn't going to help you. Guys, quick reminder, we have a test, but not Wednesday. The date was Wednesday for a long time. It's now Friday. Yeah. The test is now Friday. So our goal is to finish 6-4 today, to review 6-4 tomorrow. On Wednesday, we're going to have a class activity on all those old homework quizzes that we've done. Basically trying to let you guys get some points back on those. I'm going to have like 4 different stations around the room, one for the 6-1 quiz, the 6-2 quiz, the 6-3 quiz, and I'm going to do a pretend 6-4 quiz. Because don't we normally have quizzes on Fridays?
Yeah.
But this week we have a test, so we're going to do a pretend 6-4 quiz, just so you guys have the experience of it. And it's not going to count as a quiz grade, but it will get some points in there, which will be nice. So we're going to get some points back on our quizzes. So some of you might have put those quizzes in different locations. You want to get them all together and make sure you have them for class on Wednesday. And then we're going to go ahead and have a big old review on Thursday with that test being Friday. So I told you, I think this past Friday, that if you have a tutor, etc., you should start reaching out to them now. Or if you're like, I know I did really bad on this one homework quiz, I'm really confused about this, you can start coming in after school. Maybe today's not the best day, because we haven't started our review yet, but you're always more than welcome. Anything after school to come on in and we can work on stuff. And quite a few of you guys have taken me up on that, and I think working with the whiteboards is going to help at least a little bit. Okay, if you guys don't mind, let me pray real quick for our class. Because this week we have our first big test coming, and some of you guys, that's kind of scary. And it makes you kind of nervous, and it starts to raise the anxieties. And sometimes people respond to anxiety by being like, I'm too cool for that, whatever, because that way they're not scared of failing. They're like, I don't care. Some people get a little overconfident and say like, it's no big deal, I'm going to ace it. Because maybe some of the homework has been kind of easy, or maybe some of the quizzes have been kind of easy, and then there's everybody in between. So if we can pray for this week, and if we can pray for our test, I'm praying for you guys that let's do it together as we start off this week. Jesus, thank you for this period of 2 hours with us. Thank you for their enthusiasm, their energy, even just their ability to talk with each other and talk about life and sometimes not. But we need to focus this week, Lord, for this test coming on Friday. We want to do well since it's the first big test. So help us this week as we try to finish up the section, as we try to review those quizzes that have gone well for some and have been a trial for others. Pray that that can be a good experience. Pray that our review can be really helpful in class. And just pray that at the end of this week, the kids will be prepared as possible to do their very best on the test, but also that they can know and realize that their worth, their identity, their value is not found necessarily in their math grades. So they have the freedom, they have the ability to give their all, because at the end of the day, what matters most is your approval of them and your love for them. So help us to get some good work done today and the rest of this week in Jesus' name. Amen. Okay, so before we go over this opener, whoops! Oh, wrong direction. I don't go this direction. Do you guys remember the big idea? The big idea of growth and decay? So remember, there are these 2 big equations, and some of you guys looked in your notes as you were doing the opener, or you kind of recalled the plus and the minus, because we wrote these down on Friday. And so there are these 2 big equations. I think I even had them highlighted and color-coded as to who and what and where. Maybe you remember that this little A right here is the initial amount, how much you start with. T always stands for time, in like any math problem. T stands for time, that's who that guy is. And then this guy stands for rate. And that was part of your opener, right? Is it growth? Is it decay? And what's the rate, right? So this is that little R that we're looking for. Now, one of your classmates was like, hold on, wait a minute. I remember there are those equations with pluses or minuses. How do we know what the R is? Or how do we know the growth or decay? Here's the long story short. Bigger than 1 or less than 1? Remember how we did that whole activity? Who's bigger than 1? Bigger than 1 or less than 1? So, 72%. Bigger or less than 1?
Bigger.
Less, because 72% is actually what decimal? 0.72 or 72 hundredths, right? 0.72 or 72 hundredths. What if I gave you something like 1.3?
Above.
Above or below?
Above.
Above, because it's bigger than 1. Okay, that one's easy. The percentages are the hard ones. But what our answers is how much above or how much below. So now can we go to the opener and see how you guys did?
Yes.
First question, growth or decay? Now, hold on, no. I just want you guys to vote, because as soon as someone says an answer, everyone's like, oh, I'm just going to say what they said. Hopefully not, but sometimes that happens in different classes. So, this one, I want you to give me a thumbs up for its growing or a thumbs down for its decaying. Ready, set, go. Who is he?
Ooh.
Almost everyone. I would say like 90% of the class got it right. Why are the thumbs down right?
Decimal.
What about the decimal?
It's a decimal.
It's below. It's a decimal below 1. Careful, 1.2 is a decimal above 1. So, 0.92 is below 1. So since it's below 1, if you were to make a table and plug in with your calculators, T was 1, T was 5, T was 10. This is going to go down, 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 down. It's going to be one of those that's decreasing. Okay? So below 1 is going to be decay. Now, hold on. That wasn't the only question. That wasn't the only question. Now we want to know R. Except some of you might want to write this in your notes. Because R, the rate of change, a lot of you guys said that when I asked a second ago, who is R, what is R? But even though the big idea of growth and decay is whether that base is bigger than 1 or below 1, we might also want to write down how to find the R, or the rate of change. Because R is how much. Alright guys in the back, focus on it. How much above or below. Because R is going to be there whether you have growth or decay. So how much above or below 1. And just a hint. If it's a decimal, maybe it's not that bad. Just subtract 1 or do 1 minus. How much above or below. But sometimes you might want to, I'm going to put easier, think percent. And make 1 into, what would 1 be as a percent if I put a decimal and moved it 2?
Oh. I'll do that.
If, after, let's say we have, I don't even know what. Let's do something that grows or decays. Plants? Sure. That's okay.
Humans.
Yeah. Let's do something like rabbits. Okay. If I have 5 rabbits just chilling in here, okay? And then let's say I come back a month later, and there are still 5 rabbits. How many rabbits do I have?
5.
100%. Does that make sense? You have the same amount that you had. Now, nature would probably say that we would probably have a lot more rabbits in here as long as they didn't like die from starvation or something like that. Because I didn't really say that we were leaving them food. But anyway, it's kind of disturbing. But if we had 5 rabbits to begin with, and 5 days or a month later we still had 5 rabbits, well, we have 100% of what we started with. Nothing changed. If you have 100%, nothing changes. If you put, like your parents put some money in a savings account, and after the entire year is done, they get their accounts and they look at it like with their tax people, etc., with their accountants. If their money hasn't changed at all, then they have 100%. But it is possible if they were investing or something, maybe it went down a certain amount, or maybe it went up, maybe it decayed, maybe it grew. But 100% is like the baseline. Nothing changes. You still have 100% of what you've had. No growth, no decay, just staying the same. So if we want to figure out R, think about 100% and how much above or below the value is in this little base spot. So let's go check it out. I think percentages are easier, but maybe you'll think that like money is easier. Because if you think about this in money, wouldn't it be 92 cents?
Yes.
How far away from a dollar are you?
8.
8 cents. But you can also do that with percentages, right? Because 0.92 would be what percent?
92%.
Which is how far away from 100%?
8 percentages.
So either way, you end up with 8. But be careful. Which 8? Is it going to be 0.8 or 0.08? 0.08.
0.08.
Does that make sense?
Yes.
Because it's not 80 cents away. It's only 8 cents away. Or it's not 80% away. It's only 8% away. So how do you think about it? Probably quite a few of you could get to that 8. It's just a little bit tricky sometimes to figure out exactly what decimals to put. So you could do 0.08. Wait. It doesn't just say rate. What does it say?
Percent.
Okay, so maybe the 0.08 was one step to get there, but we can't stop there because they actually say they want the percent. So I don't mind that you're 8 cents from $1, but after you get the I'm 8 cents from $1, you're going to have to say, oh, okay, but for the final answer, that is 8%. Okay? Now, as we go to this next one, give me a growth or give me a decay. What do you guys think? Thumbs up, thumbs down. Party poopers. I heard growth from everyone. Thumbs up everywhere. It is growth. It is growth. Why is it growth? Because 1.2 is what?
Greater than 1.
How much? That's our key question.
By 20%.
By 20%.
Wait, I thought it was 100%.
Well, that's the hard part, right? So when we do the rate, we ask how far away from 1. So this one was 8 cents from $1. This one is, well, if you guys wrote it, isn't it 20 cents over $1? So it's either how far under or how far over. It's either how far for our rate of change, how much it's changing by. So whenever you guys see something like, have you ever watched those car commercials where it talks about like APR, like 0% APR for the first time? It's trying to talk about the interest on the loan, because some people buy a car, but not with like, hey, here's the cash, I'm totally paid off. It's usually like, hey, let me take out a loan and I'll pay it little bit by little bit, month to month. And there's interest on that loan, which means, okay, well, that was the price tag, but you're going to pay a little extra because we lent you money every single month. But the loan doesn't say, oh, you're paying 100 and something percent. It just says the little bit extra that you're paying, which is why you guys see little things like 0.08% APR or something like that. Same thing with credit cards. Take personal finance to learn about credit cards. But you're just asking yourself how much above or how much below. This one was 8% below or 8 cents below $1. This one is 20% above. You can take 20 cents more or 20% above. Andrew, you had a question. Go ahead, bud.
Yeah, so you know how you say if below 1 is decay and above 1 is growth?
Good.
What if it is 1?
Then it's our 5 rabbits stayed 5 rabbits, nothing changed. So your rate would be 0. Because it's not off of 1 at all. Which isn't like a very normal growth. Usually either something's decaying away or growing. But yeah, if it was 1, 0 would be your rate.
So confused on the decay one. So why is it 8%?
Oh, with percentages, remember that we move the decimal places 2 to the right whenever we're doing a percent, like when we're doing from decimal to percent. Or the way that I like to think about it is you had 92%, which is what was being used, and we're trying to ask ourselves how far is that from 100%. So 100 minus 92 is 8. You're missing 8%. Does that kind of make sense? Yeah. So if you were to take the normal, move it 2 decimals, 100%, how far from 1 is also how far from 100%. But if the decimal does make sense, Andrew, you can't just think 8 cents away from $1 and then boop, boop, there you go. Andrew Swanson.
All right, I have another question. For number 1, and for the direction test says rate of change.
Yeah.
That's why we put 8, right? If it was just rate, we put 92 behind.
Yes. So it's specifically how is it changing? Oh, well, it's decreasing by 8%. That makes sense. Okay, now, I do have some other examples. Oh, actually, you guys have homework problems like this too, right?
Yeah.
Okay, can we just stay in your opener? I didn't want you, we're going to do it all together. You won't have to do it by yourselves, because as soon as there are words, we start to get a little more confused. Let's go over these 2 more examples, and then I have your answers to the evens actually waiting. But I knew that homework, there were 2 types of homework. One was like this, and one was like this. So I figured let's do a couple examples. That way, when you go to grade, maybe you'll have a little bit deeper understanding. And you guys were trying to practice it over the weekend, but it's been a whole weekend. So, what is our goal according to the directions? All together, just in your opener numbers 3 and 4. What's our goal?
To make a function.
Good. To make an equation. And that's like what Kayla was asking me a second ago. That's the one that has the 1 plus r to the t. Or 1 minus r to the t. But who's who? Which one's this guy? Growth. Because it's going above 1, right? And who's this guy? Decay, because it's going below. Okay, so we have to figure out between 3 and 4, which one's growth, which one's decay. I'm assuming there's one of each. Maybe I'm wrong. But can you guys read the number 3 scenario? Your starting annual salary of $35,000 increases, hopefully it does, we live in LA, increases by 4% each year. So growth or decay?
Growth.
So you guys take like personal finance, you'll do this thing where you'll budget how much money you would need to survive just to like rent a very basic room or apartment. Yeah, $35,000 would be a little rough. Better than some. Something to be thankful for. But some of you were wondering the whole LA culture. Growth. So if we're doing growth, we can look to this equation, right guys?
Yeah.
Okay, cool. So I have y equals, what can I put in that A spot? Do you guys remember what A stands for? It does in some examples, like equals. Yeah, it does. Force equals mass times acceleration. F equals ma. But in money or in exponential growth, it stands for amount. A stands for amount. So kind of like A for acceleration, A for amount. Amount. Oh, what I started from. Kayla said it really nicely. Initial amount. So I'm going to throw in that. Okay, I'm starting with 35,000. Other examples might talk about like a piece of clothing at a store being on discount, being marked down. That's what would go here also. We're saying, okay, what is the quantity, what is the amount that's being increased? 35,000. And then, nice thing is, both equations say 1, and then we said growth, so 1 plus, and how much is this going up by, guys?
4%.
4%. Now, careful. Should I put a 4, and this becomes 5?
Point.
Yeah, you gotta be careful. Think 4 cents, 0.04, not 0.4, that'd be 40 cents. If you guys need to, remember, you can put the old decimal and move it 2 places to the left, right? You'd have 0.04. And then I can throw in that t. And the nice thing is, technically, you would be totally right if you did that. Maybe a little lazy, but I already told you guys I'm lazy sometimes. So we could just leave it like that. Or if you did 1.04, you would also be totally right as well. So I'm going to throw an or in, because this is also fun. Sometimes problems look like that, and sometimes problems have it simplified like the one below. But either one's good. You guys see how it's 4% over? 0.04 over. So your turn, number 4. Ready, set, you think through. Is it growth or is it decay? And what would the equation look like? Your turn.
Decay.
Yeah, I agree. What would the equation look like? Oh, you ready? Ready, someone with an answer? I want you guys to all write down what you think the equation might be. What do you think? Based on what we just did, what would the equation look like?
Number 4, right?
Yeah, number 4. What would the equation look like? I'm seeing some good stuff.
I got it.
I think I heard a lot of you guys knowing it was decay. What was the key word that you guys picked up? Decrease. Good. Okay. From those of you that started writing down the equation, I totally agreed with you putting the 900 first.
One plus.
Gotta look out for those keywords. Okay, what went next? I saw a lot of you with writing.
1.
1, but then
Plus.
minus.
Oh wait, never mind. .09.
Now, if you guys used your calculators, you would have gone ahead and subtracted. You would have gotten 0.91. Does that make sense? That would have been 0.91? We can stop here. That's okay. If you're 9 cents away from $1, you'd have 91 cents, right?
Yes.
All right. If you guys think you're okay on this ish, or at least better after the weekend, can you give me a quick thumbs up? It's like, I think I'm doing it. Hey, look, you're all growing. Anyway, coming back. Let's check our homework. Here we go. Evens. Not like that. All right, here we go. Let's check our evens. So turn to homework. I'm going to go ahead and walk around really quickly and see that you have a homework that you are grading. Now, homework, careful guys, you had to be plugging in some numbers. Right? Did you have to plug in C equals 5? I'd use a calculator. Alright, Isaiah, Ray. You guys get distracting when you get all excited. Alright, we're grading our homework right now, yeah?
Yes.
Okay. But be careful. Some of these you had to be plugging into your calculator, and it's very possible something could have gone wrong. It happens. And some of you might not have totally known how to plug this into your calculator because it does get kind of weird and lengthy. Take a little bit of time.
You're good.
Alright guys, you all have calculators, or at least most of you do, right? So let's go ahead and, I just need a volunteer really quickly to help me out with, well, I'm just curious, it's kind of hard, because you have to meet a certain condition. I'm curious if anyone in here is brave enough to tell me one of the plugging ins that they got wrong. Because I want all of us to make sure we can use our calculators, because we need them for this section. Does anybody have one they got wrong? Yeah.
For the rate, I got 38. For the whole thing, I got 38.
This is okay.
Which number?
Number 6.
Number 6? Okay.
About 38.
Okay. So let's go go ahead and check number 6 really quickly. You guys have your calculators out, right?
Yes.
So for number 6, I think, especially for those of you that wrote down the problems, I think it would have been something like y equals 10 times 1 plus 0.4 to the t. Does that look about right?
Yeah.
Okay. You can rewrite that to be 1.4. It makes it a lot easier in your calculator if you actually put those together if they weren't already. But at the very end of the problem, guys, okay, you pulled out that this was your initial, 10. That was your rate. 0.4 is 40 cents or 40%, right? Take a breath, you're fine. Okay, we're coming back. How did they get 53.8? What were they asking, Caleb? What were they asking you guys to do for these homework problems at the very end? You were supposed to, well, I think for these two. Oh, I think these were the ones that you were writing the function for. These ones you were trying to identify and then solve or evaluate when t equaled 5. Good. So in your calculators, can you guys get 53.8 when you plug in t equals 5? Go ahead and double check, make sure that you can. Some of you had calculators, you're doing it this weekend, some of you are not totally sure. Each calculator is a little bit different. Do you know how to find the exponent button? Now if you don't, you could have done this the long way. Of 10 times 1.4, how many times?
Oh.
Yeah, you could have done it this way. Like, it takes a while. It takes a while, but that's one way. But then there's also a really cool exponent button. If you don't know where it is, turn to your group really quickly and let them try to help you. If you know how to find the exponent button, it makes life so much easier if you can do to the 5th power. Yeah, go ahead.
I have a question. I got 75% for the rate.
For number 6?
Yeah.
Caleb.
Oh, never mind, I'm good, I'm good.
You have your lock.
Yeah, I got more.
Well, 5.30.
Yeah, good. That's the nice exponent button. You guys find it okay? Anybody other calculators not able to?
Oh, is this
Yeah. Okay, so some of you guys realize that when you were to plug in, you get 53 point, I think, 78? 75? 78? Okay, 24. But they went ahead and rounded it to the nearest 10. That's why they went ahead and looked at this, but then they said, okay, whenever that, remember, following decimals above 5, we round up. Which one is that one, right?
I know, 5.
Oh, it doesn't make it look long.
Oh.
This is your little extra. That's a weird one. Alright, guys. I want to get you guys ready for homework tonight. So let's go ahead and take a deep breath. There have been chances for you to talk today. You were talking to each other about calculators, you were talking to each other about the openers, but now's the time to stop talking. So I want you guys to be ready for that homework tonight. 33 through 38 and 41 to 48. So let's see if there's anything extra in homework beyond what we've already done. So in number 33, let's check it. Through 38. Uh-oh. What's this? Oh, can you guys see it? Is it too zoomed out? What's different? Tables. Oh. We haven't talked about tables this section at all, huh? So hold on. I wonder if I have any notes to help us on tables. Oh, that's not you guys. That'd be scary now. In your notes, we have about 5 minutes left. Let's pull ourselves together. Compose ourselves a little bit. We haven't talked about tables yet in this section, so I thought we should just go over a couple hints. Okay? So in our notes for tonight's homework, there are going to be the tables. Not the whole thing, but that first little section of homework. You're going to be looking for patterns and tables. Now, the dealio is, you guys actually already saw a pattern in tables for exponential functions. In homework section 6.3, you're talking about, there it is. There were tables. There were tables. Because these tables, the exponential ones, look way different than the linear ones. Maybe they didn't look that much different. A few of you got tricked. Yeah. Yeah, they are. It is. Linear has an add pattern. Add the x's, add the y's. Exponential has an add-multiply problem, but you can be multiplying different ways. So do you guys see how both the y's are multiplying? So since both the y's are multiplying, we know right now that both of these are exponential. Now you guys had in your quiz on Friday, you had some tables. I think you had 2 different tables. And you were trying to see if either one of them was exponential. One of them was, one of them wasn't. The way you could pull out the one that was is you had to look at the values, which were smaller than this. Because these are kind of hard to see. Well, maybe not, because 3 times 3 times 3. But you were trying to see, oh, times 2 times 2 times 2. On Friday, you were just trying to find if either table had an as the x's add, the y's multiply pattern. But here's the struggle. Today, they're both multiplying, they're both exponential. That's not the question. The question is which one is growth and which one is decay. They both have multiplying, which is good. That means they're both exponential. On Friday, you should have circled both of these, because both of them are times, 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 or you could say divide, divide, divide. But which one's a growth and which one's a decay? B is, I heard B. B is which one? Growth or decay? Because what are the y's doing as the x's go forward? Yeah, they're increasing. Good. They're increasing, they're growing, and they're multiplying by 2. Yeah, they're doubling, which means the rate is something higher than 1, or the amount is something higher than 1. But over here, this one is going to be decaying away. So if it helps, you can think about decay as division. Kind of. I know it says times 1/3, but most of you would probably see this a little better as dividing by 3. Because you divide by 3, divide by 3, divide by 3. So they aren't wrong when they say times 1/3. They aren't wrong at all. But maybe like the shortcut is to think about it as dividing or going smaller, decreasing. Whereas growth is getting bigger or increasing. So with this little bit of notes and with these couple hints, I think you guys will be okay on 33 through 38. But have your calculators close, because even though these y's are kind of easy to see, the ones in the tables might be kind of more messy, might be a little bit more complicated. But do you guys see how there's one more section of homework? Can we pop there real quick just to see what it looks like? Okay, so these ones, 40, where are we at? 41 through 48. Here we go. Okay. 41 through 48 says, determine whether each function represents growth or decay. Oh my goodness. Guys, check it out. What does this look like? It's like the opener. It's exactly like the opener, right? Because you're trying to figure out whether it's whether it's growth or decay, and what the R is. So what I want you guys to remember tonight for this homework is, don't worry, I'll wait until it's quiet. I just don't want you guys to be partying for temple, but where's this work? Okay. Just like the opener, Nice thing is, don't your homework spirals already have the opener? Were you doing
Yes.
homework? Okay. So you're supposed to identify growth or decay, and then when it says identify the rate of change, R, how do we find R again? Can someone describe to me R again?
You move the decimal.
You can think moving the decimal to make percentages. How far away from 100%? Anything else, Daniel?
I think you know money.
Yeah, I think money might help for a lot of you in the sense of, remember, how much above $1, and if it's above, what are we doing? Growing or decaying?
Growing.
Or how much under $1?
Decaying.
In that case, we're decaying. But be careful of your decimals because that can get kind of tricky, especially when going from the money to the percents. So if that's a little bit tricky for you, maybe even think percents. So just as a quick example, kiddos, growth or decay, number 44. Growth. By how much? R equals 8%, or 8 cents turned into 8%. Does that make sense? Okay, so as you guys are getting ready to leave today, if you didn't write this in your notes, if you guys didn't realize it, this is a really, really, really important page that you might want to take a picture of if you didn't get to write it down. Because for section 6.4, this is like the huge idea that I want you guys to remember, and I'll probably be testing on from section 6.4. Growth decay equations, whether the base is above or below 1. And that R is how much. Above or below, you can think either $1 or how much above or below 100%. So homework is on the sideboard. If you guys haven't gotten it yet, write it down. The big idea is 6.4 is up here, and I'll see you guys tomorrow. Sound good? Woo! Back to chapel. Calculators. I'll have my things by the door.